Okay, I believe we're live. And let's see, Immutable Destiny, who is the late Immutable Destiny, will be talking to Otangelo in about 5 minutes. But I don't know what else is going on. I've been. Hang on a second. I gotta shut that off. I always do that. I've been studying information theory and biology today, and found a bunch of very fascinating books going all the way back to, I think, around 2000. But they have papers in them that go all the way back to 1968 is the earliest, talking about biosemiotics and biology by Wills and Patty. You ever heard of them?
No.
Okay.
I know that Barbieri, he has some books, good books on biosemiotics.
Who does?
Barbieri.
Oh, Barbieri. Yeah, I've got his book on. I've got his book right here. No, I got Hoffenmeyer. I don't have. I think Barbieri. I've got it in PDF form, but I've got one here by Jesper Hoffmeyer, and I think he has papers in here by Barbieri. Got a bunch of papers.
Codes, an introduction to semiotic biology. That was in 2002. Then in 2006, introduction to biosemiotics.
Are those books?
Yeah, I can put the link here, so anyone that wants to download them can do that.
I think I've got his introduction to biosemiotics.
They are good books. I like them, but he doesn't make the leap to intelligence. So for him, everything, the origin is all materialistic, is material. So he is a materialist.
Springer did a series of books. They're up to volume 14, I think, on biosemiotics right now. We have, let me see here. I've got Essential Readings in Biosemiotics by Favreau.
I don't know these.
And let's see here, Information on Living Systems by George Terzis. And then Paul Davies has one.
Yeah, Paul Davies is I like Paul Davies very much, but he also, now he goes that far to say that the multiverse hypothesis is stronger substantiated, and that more physicists adhere to that idea. And that sounds so crazy to me, because there is absolutely no evidence for this. But I can understand it. When you want to exclude a creator at any cost, then that's the direction to go. There is no other explanation of fine-tuning than multiverses. So, and
Immutable's here. Okay, so I can take a backstage. And
if you want to. I heard fine-tuning, and it's a shame that fine-tuning is nothing more than an assertion.
You guys.
No, that's a fact. That's a scientific fact. That is not disputed.
Okay, hold on. What facts do you have that our universe is finely tuned?
I can put the link here. There's so.
No. I'm not asking for a link. I'm asking for what specifically do you think about the universe, or in the universe, is finely tuned?
Well, we can start with the Big Bang, with the cosmological constant, then with the four forces. They are fine-tuned. The atomic forces.
Okay, let's cut to the meat and potatoes of this. How many times have those events occurred, like the Big Bang, or how many instances of the value for the gravitational constant do we have?
Well, of course, the Big Bang occurred just one. Just
right.
one. So what?
Right, but so the issue that you have there, right, is that to make any kind of statement about whether or not something is unique, let alone being finely tuned, a statistical sample of 1, which we only have, means absolutely nothing.
Well, you should argue. You should argue with cosmologists, not with me.
I've heard cosmologists make the same argument.
Yeah, so if you disagree, go and argue with them and disprove what they're saying.
Well, yeah, but the issue is this doesn't even come down to a philosophical difference between me and you and worldviews. This is simply mathematical. This is simply a matter of saying, if you just have a sample of one thing occurring and data from that one sample, you can't tell anything statistically in regards to the nature of that sample or phenomenon that are occurring.
Well, they know that if the values would be different, if the expansion rate of the universe would be different, they know that then it would either collapse into itself or it would expand so fast that no matter would be formed and no stars and nothing else. So
okay, the issue though fundamentally is that, for instance, the value of the gravitational constant, so gravity itself is a geometric description of space-time. And the fundamental issue there is that if space-time is different ever so slightly, or there are other things in the universe that are different, such as the proportion of matter or other physical laws that have changed by 1 iota of a bit, then it can compensate for those changes. The issue you're calling of fine-tuning, the typical argument that's made only accounts for one variable, when in fact these variables depend on each other very strongly to form complex structures we see in the universe. And the thing is, we don't know, number one, if those values can be changed to produce a universe that has different properties, let alone lifelike ones. But there's strong mathematical argumentation that suggests that it should be at least potentially the case. Mathematical models like string theory say that there are certain values that the gravitational constant and cosmological constant and other constants should be able to take on that also achieve some level of complexity. Now, it might not be the same level of complexity that we have in terms of life, but simply saying that if we just change one thing, it's going to cause things to go out of whack, I could probably agree with that. But we're not just talking about one system itself in isolation. We're talking about multiple systems that are heavily interacting with each other to form complex structures. And so it's more an issue of how do you change things in context? How do you change multiple things? Like, it's a simple example for people that are following along with this is like the example of a chocolate cake. There are multiple ways to make a chocolate cake. It uses the same basic ingredients. So, I mean, it uses flour, it uses sugar, it uses eggs, it uses milk, right? These are all ingredients that are needed to make a cake. And nobody's saying that if we take one of those things out, we'll still have a cake. What people seem to be arguing about more so is that, okay, if I use more yolk or if I use more egg in this, would I have the same quality of cake? Would the structure of the cake be different? And the answer, more than likely, seems to be yes. But like anything else, and even to the example of what we're calling and what we're discussing, is this issue of there's ways in which you have to change things to get the same result. And mathematically, and we don't have a physical understanding of how that can occur yet. But so the point this originates from, which is still valid, is that you can't base that type of conclusion just based upon one sample. We don't know of other instances of the universe having other constants, and we don't know whether those constants could be habitable for life or anything.
Okay, can you or Speed put the link here on the screen? If I don't be wrong, I think that we had already this discussion at another opportunity, but I would like to read this here. In most analysis of the fine-tuning of the four strengths and constants of nature, only one parameter is adjusted at a time to make the problems more tractable. This would correspond to changing one dial at a time on our universe-creating machine while leaving the other dials unchanged. Even taken individually, each of these examples of fine-tuning is impressive, but in the real universe, the values of all the constants and four strengths must be satisfied simultaneously to have a universe hospitable life. So
this was the point I was talking about, is that I agree with the point, and which is why I was saying when we're considering fine-tuning, we should be considering more than one variable changing at a time. We shouldn't just strictly be concerned with how one variable changes and how that influences a system.
Well, John Gribbin, he goes further, and together with Martin Rees, he wrote the book, and he said, if we modify the value of one of the fundamental constants, something invariably goes wrong, leading to a universe that is inhospitable to life as we know it. When we adjust a second constant in the attempt to fix the problem, the result generally is to create 3 new problems for everyone we solve. The conditions in our universe really do seem to be uniquely suitable for life forms like ourselves, and perhaps even for any form of organic chemistry. So
Okay,
this
and the issue that
this basically says it's either everything or nothing. Either all the constants are precisely tuned as they are, or a life-permitting universe would not occur. And that, of course, requires an explanation.
No, I think what's being pointed out here is that there is a specific type of way, if it is possible to change fundamental constants, they must be changed relative to each other in a very specific way. A random assortment of these constants will not work.
Yes, you are basically paraphrasing
Right.
what I just read.
Right. But so the issue comes down to, with models like string theory, like I said, there are mathematical structures that predict, for instance, that there is a special way in which these things can be changed in synchrony with each other that potentially can form complexity, although maybe not life.
Well, first of all, string theory is basically something which is not Azure anymore. They have put it behind. And secondly, even if we let's suppose that we take that as a model, which is hypothetically still possible, there are 10 to the 500th power of possible values that you can select from, and you have to choose amongst this huge variety of different constants to have one which is also life permitting. And of course, there is no. If you stick to materialism, there is no selection process there, which unless randomly, and to select in such a huge sequence space or possibilities, that is something in the realm of the impossible.
No, it just boils back down to a basic teleological argument. String theory at its core, I mean, people are still working on string theory in terms of its geometric composition, because the current formulations of string theory operate under a type of space-time that we know does not, that the universe does not occupy. So that's trying to be corrected for. But even more so, string theory is a probabilistic theory, and there is no compunction for these fundamental constants to choose a value that will favor life. They're going to randomly, essentially, what values come out are going to be random. However, those that are suitable to form life will form life, and those that aren't won't. It's not very complicated.
The idea might not be complicated, but if you have to select amongst 1 to the 500th power, I mean, the size of that number is much bigger than the number of atoms in the universe. So we are talking here about hypotheses which are extremely unlikely.
Well, the issue is there's certain models of the universe, and there's some people that'll say it's very strong. I'm not claiming anything about whether or not these models are true. There are models that say that essentially the universe will reset itself after a specific point in time, because according to various cosmological models, all the matter and energy in the universe, well, all complex structures we have fade due to being absorbed by black holes. the fundamental point being that if the universe operates under a cyclic model, being that once complex structures are destroyed, the universe essentially restarts back to the point of a Big Bang, then essentially that process will be a new random selection of these constants we're talking about. And this is occurring infinitely. I'm not saying that's true. I'm saying that that's an argument that can be given for it, though.
Yeah, the cyclic universe is also a model which has fallen in disgrace, let's say. Like Vilenkin, for example, he states, disorder increases with time. So following each cycle, the universe must get more and more disordered. But if there has already been an infinite number of cycles, the universe we inhabit now should be in a state of maximum disorder. Such a universe would be uniformly lukewarm and featureless, and definitely lacking such complicated beings as stars, planets, and physicists. Nothing like the one we see around us.
Yeah, and we don't know why it is in the beginning of at the beginning of the Big Bang that these structures started to form. We know that expansion began to occur, and we understand that because of very dense regions that energy was occupied in, it began forming matter, or converting energy into matter, rather. But the second law says only that entropy in a system must decrease. So as long as it decreases over time, everything is fine.
Yeah, but it cannot decrease in an endless amount of time. There will be a point where the universe will be in a state of heat death, and then nothing will occur anymore. And that points to an absolute beginning of the universe, which was extremely ordered, which was in a extremely high entropy state. And of course, that demands an explanation. And I, as a theist, I have an explanation, but a materialist will have his problems to explain that. And of course, you can always resort to, I don't know, but I don't know why that should be a reasonable cop-out if we know that
it's not a cop-out. It's the only intellectually honest answer that can be given to that type of question. The fact of the matter is that since the 1960s or 1970s, but either way, for the past like 50 to 60 years now, there are fundamental issues within physics, such as the unification between gravity and the four other forces, that essentially prevent us from having a grand unified model of physics. And essentially what that means is that the mathematics we have that unify the three fundamental forces break down to a certain point, and it breaks down to like fractions of seconds after the Big Bang occurs. There does not exist a physical theory as of yet that explains the state of the singularity before the Big Bang. There is, and as far as we know, the cosmic microwave background gives us a slight problem in being able to try and measure beyond that point. Because during very early parts of the Big Bang, particles such as hydrogen and helium nuclei were formed. And part of that process is that since matters became coupled, so to speak, photons of light could be emitted because that's a way that molecules can give off heat. And that gives us light, which we can still observe to this day. But prior to that point, we can't see anything past that. And if there are other ways of trying to get an idea of what came before that came before a world where photons could be emitted, we don't have currently a method of detecting that. So there is no explanation, at least in terms of either a model, a scientific model, that can explain that type of state, that can explain the very initial state of the universe.
Okay, it cannot explain it, but we know that you cannot have an infinite amount of time in the past.
Why not?
Precisely because energy winds down to a state where the universe would be in a state of heat death, and nothing would go anymore. And you cannot reset to an initial state and trigger a new Big Bang. That's precisely what I wrote, which Vilenkin said. So I think that. Yeah.
I think this is still very much so an open problem on. I think this is still very much so an open problem in modern cosmology, and there are physicists I can cite that would disagree with us. So I think on this particular point, it's kind of a moot point. There's people that disagree. There's people that will agree with you and me. Although the second law itself, remembering it now, only applies to closed systems, which means that it applies to systems where essentially matter cannot interact with a system, but energy is allowed to flow in and flow out of a system. I think the most honest thing we can say is that cosmology is a very complicated thing. The more we learn about it, like for instance with dark matter, we still don't know what dark matter is comprised of. For instance, that may play a very large role in the very early infancy of the universe, and in regards to if there's a new fundamental force to be discovered. But I think the most fundamental, the most honest thing we can say fundamentally is that we simply do not know enough about the universe currently, both mathematically and observationally, to be able to say about what the most likely state for the origin or for the initial state of the universe to be.
I mean, if you are fine with that and saying, I don't know, that's up to you. I think that what we already know is enough to say with the majority, I think, of cosmologists that most likely the universe had a beginning, which of course then has theological implications. And of course, if you say we don't know, then you are avoiding these implications. And I mean, if
No,
you are fine
my framework, at least, is that I will only make claims for things which are based upon evidence.
Yeah, but I mean, we have good evidence that the universe had a beginning, and it is a position defended by the majority of cosmologists, I would say.
What we understand about the universe is that there are moments before the Big Bang, and there is some very convoluted topological structure associated with it. And it does seem to be the case that there is something or some mechanism in which that caused the universe to or that caused the universe in that particular state in time or that particular epoch of time to undergo expansion and exponential expansion at that rate. Now, that might be inflationary theory. That might be certain particles of dark matter to be produced that cause that expansion. It could be some other thing. It could be some type of energy we're not familiar with, and that's extremely exotic. But simply, we don't know what that is. Dark energy and dark matter are still very open problems in the field of cosmology, and we don't know, number one, what dark matter is in terms of what it's comprised of, and we also don't know what role it plays. We don't understand its significance in terms of the bigger picture when it comes to the very early origins of the universe.
Yeah, I'm putting here a link in the side chat so everyone can access it. I have a collection of information in regards of that topic. You can, after our chat, also have a look on it. But I think the first sentence here is relevant. According to Hawking, Einstein, Vilenkin, Penzias, Jastrow, Krauss, and the hundreds of other physicists, finite nature, time, space, and matter had a beginning. And,
sure. The thing is that we do not understand what caused the universe to expand. That is the biggest question. regarding cosmology is what reason, or why is it the case that the universe began expanding in the way that it did? And why did it go such strong periods of expansion very, 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 very quickly after the Big Bang? That is the question. I mean, I don't think people are arguing about a creator, at least on people in terms of the science field, because that's not what science does. But
Yeah,
also,
it is a philosophical question. But important here is to say that the scientific evidence and the philosophical thought exercise grants me perfect rationality in sticking to the view that the universe most probably had a beginning. And of course, then we go with the Kalam or cosmological argument and believe that God triggered the Big Bang. And I think it is well established, and it is rational to hold to that view.
yeah, I think the Kalam fails for a few reasons, but even if you want to go down irreducible complexity or complexity itself, I don't think the argument is consistent.
Well, of course, if the universe had a beginning, it had a cause, because the universe could not have emerged from absolutely nothing. And of course, the debate is about virtual particles. We can go down that rabbit hole, but that is also then it raises the question: well, what caused the quantum vacuum, which causes the virtual particles into existence? And then you are again at the same question. Something had to cause everything to start, to trigger it, and you cannot posit nothing because nothing has no causal powers. So then you have basically the option that it would be another material cause, or it would be a non-material cause, or an intelligent creator. There are several different explanations to that.
To my knowledge, what you're describing as the virtual photon problem isn't a problem. As far as I know, what's being described here is very analogous, at least, to what's called the Casimir effect. The Casimir effect was observed in the 1930s, and essentially what it was is that they essentially placed two metal plates very, very close to each other. So within fractions of a billionth of a meter between each other, so very, very close. And over time, what was observed is physical separation between the plates. And the question for this was, how does this occur? And the ultimate result of that is, according to very complicated physics, there are particles called photons, which are the result of excitations in electromagnetic fields. These particles are produced by random fluctuations in quantum fields, and high energy photons, when they when they collide with an object, they give off energy to it. And as the result, since these plates were very, very close to each other, what was happening is that only photons could be created that were of a specific wavelength. And as a result, when these photons were produced, they would inevitably crash into these plates. And as a result, the momentum that these photons carry, because they have energy, would cause these plates over time to separate. Now, the reason I say that is essentially what was being observed is that when you have a very, very compact region of space, and you have essentially something which acts as a boundary for that, space, you can compare black holes, because the event horizon of a black hole is very, very small, and it prevents matter from escaping. To some extent, you will have a very large number of high energy particles that will get produced and that will give off their energy to that system and over time cause expansion.
Yeah, again,
So-
that raises the question, where did all this come from? It cannot be infinitely old. It had to have a starting point.
I don't see why. If it's possible for photons to be produced spontaneously just by random fluctuations in quantum fields, which aren't made of nothing, right? They are essentially they're just a place where energy can be quantized or not quantized. I don't see why it's the case that once the universe returns back to a state of just having energy, that the same process can't occur.
Well, they would be in time, and if you have time, you have change. And if you have change, you cannot have infinite time back in the past without a beginning.
So the issue in this case becomes one of the ways in which we measure time, or one of the ways in which we think about time, is by thinking about objects and how they are positioned relative to each other, right? If I have an object on one side of my room and an object on the other side of my room, say a tennis ball and, I don't know, a wooden board, I may throw my tennis ball at the board and I may say, okay, there's time that's passed because it took so long, or there was some change between where this ball was at one point and, well, where this ball was in relation to this board at one point in time and where it was in another point in time. The notion of time kind of depends on a notion of objects and a notion of there being different types of objects. In a state where we don't have observers, where there is nothing really to discern between, say, a photon or a gluon or any other elementary particle, they essentially look all the same, even if they're not. And it doesn't make sense in that case to refer to something as having a property of time.
Okay, Speed, can you put that link here on the screen, please? Okay, it is claimed that virtual particles are indeed real particles.
Wait. Did you put it in chat first? We have to link everything we put on the screen.
Okay, just a moment. Okay, I'll put it here in the chat as well. And you can put it in.
Thank you.
Sorry. Okay, it is claimed that virtual particles are indeed real particles. Quantum theory predicts that every particle spends some time as a combination of other particles in all possible ways. Quantum mechanics allows and indeed requires temporary violations of conservation of energy. So they are in time, in space, and require a quantum vacuum in the lowest state of energy. So we have to ask, what caused the energy, space, and time in which these particles pop up? So basically, you have not solved that question.
So the answer for that one is basically nothing. And the reason for that is when we describe the universe, and this is for any science, what we are describing at some level, so if you ask a particle physicist or you ask a physicist that's studying cosmology, in large sum, what we are doing is we're studying the universe in some properties of its energy and some properties of its composition and how those things have changed over time. For instance, well, the relevant point I'm trying to make is that energy and matter are things that exist. They are something that do not have a cause. They are essentially brute facts. And the geometry of space-time is the same type of way. The geometry of space-time essentially just means that it's a description of space that these particles live in. there isn't anything that causes it, because for it to be caused, there would need to be something acting on it. And that doesn't happen unless those particles already exist.
Well, you are claiming something which I would say that the big majority of cosmologists, they would absolutely disagree with you.
I think everybody who is in cosmology would agree that matter and energy are both properties of the universe that are eternal. The first law of thermodynamics states that neither matter nor energy can be created nor destroyed, which you may ask, okay, so why is it that in the very beginning of the universe there's only energy and no matter, but that later there is no matter, or later there is matter in the universe? There are complicated ways in which energy can be converted into particles that contain mass, and that can occur because, according to Einstein's equations, energy and mass are the same thing. E equals mc squared. So some amount of energy is the same as describing some amount of mass in the universe.
Yeah, Bordegut and Vilenkin were able to prove that any universe which has, on average, been expanding throughout its history cannot be infinite in the past, but must have had a past space-time boundary. In 2012, Vilenkin showed that models which do not meet this one condition still fail for other reasons to avert the beginning of the universe. Vilenkin concluded none of these scenarios can actually be past eternal. All the evidence we have says that the universe had a beginning. So he is basically contradicting you. And Arno Penzias also said, astronomy leads us to a unique event, a universe which has created out of nothing, one with the very delicate balance needed to provide exactly the right conditions required to permit life, and one which has an underlying, one might say, supernatural plan. So they disagree with you, and I basically go with what they say.
So like I said a few minutes ago, I think this field of cosmology, this particular topic of the universe and its origins, although it's not necessarily young, there is a lot of attention in it, and there are still new models continuously being generated to try and explain how these things occur. People like Alexander Vilenkin will claim what he wants to claim. There are still other people that will claim otherwise that are also professionals in this field. I'm not smart enough to say which of them is correct. I think that they all are basing their arguments on logic and sound reasoning, but I don't think we have enough to say which one's going to be correct ultimately. There's very much so a sense in which certain physicists will agree with Alan Guth, who is the founder of inflationary cosmology, but there are also people who will agree with Vilenkin, who want to make the claim that there is some kind of essential time boundary for how long the universe could exist in, and that cyclic models can't occur for whatever reason.
Yeah, I mean, this is of course is just one argument, but what I have is a cumulative argument for God's existence, and that starts with the existence of the universe itself. Then it comes to the laws and rules of mathematics and physics. Then we go to the physical universe, and the laws of physics are interdependent and irreducible. You need one to have the other. Then comes the fine-tuning. So you have basically four problems, which you will run into big problems if you try to explain these things by material mechanisms. But if I posit a creator, a powerful creator, he can trigger the Big Bang, the beginning of a universe. He can formulate the laws upon rules upon which then the physical universe will operate. He has the power to make everything finely tuned in order to permit life. And then I can go on. I mean, then we can go to other arguments. But what I want to say, Immutable, is that the theistic worldview has so many things which are in its favor and which make and permit to make a rational and plausible a case for theism.
I don't see that. What I've observed from the universe is that, in fact, the history of all humanity is that when humans have been challenged with something, be it to try and understand, for instance, what lightning is, so this is a question that the Greeks and Romans and other civilizations prior to those civilizations were trying to deal with, the original answer was, oh, it's a god. Oh, it's Zeus. Oh, it's whatever. It was something appealing to the supernatural until somebody managed to show that, no, actually, there's these things called electrons, and there's things called electric and magnetic fields that, by fairly nuanced physical laws, not necessarily complicated ones, but if you have these mathematical laws, you naturally generate these electric fields and magnetic fields and other phenomenon that go along with it. The point being is that I think for the entirety of human history, when we've asked questions about how does something work, the answer has come back time and time again that, oh, there is some natural explanation for this. The supernatural, as long as it's been tested, I don't think has actually served as an answer for anything.
Well, I disagree with you. I think that everything points to a creator because laws require a lawgiver. Fine-tuning requires a fine-tuner. And codes require a coder. Information require an information generator. And I can go on and on. And these are not arguments of gaps, you know. These are arguments which are positive claims where we see a phenomena and then it points to a creator. I have listed 17 different things. I can quickly read them to you. We know the universe at the beginning, therefore a cause. So we know the universe obeys laws of physics, therefore it needs a lawgiver. We know the universe is finely tuned for life, therefore it requires a fine tuner. We know cells are factories in a literal sense, the factories require a designer. We know that cells are irreducibly complex, they had to emerge all at once. We know that cells host genetic and epigenetic codes. Codes come from intelligence. We know that cells host instructional complex information, which must come from a mind. We know that cells process information like computers. Computers are always designed. We know that consciousness and intelligence can only come from pre-existing mind. We know that the mind and consciousness are separate from the brain. Dualism is true. We know that organismal form is explained through codified information and signaling. We know that objective moral laws are owed to beings, and since they exist, they come from God. We know that historical facts described in the Bible are confirmed by archaeology. Then I go on with theological arguments. So these are all arguments which are grounded by positive evidence, which permit logically to infer a creator as the best explanation of the phenomena in question.
It's still amazing that despite me and you having talked about this, that you still misunderstand or don't actually understand what a scientific law is. Because it's not something that's prescriptive, it's something that describes a phenomenon. I can point you to multiple scientific sources that claim this, and that even historically will give you that is the case.
Okay, Speed, can you put this link here? I will put it here in the side chat here on the screen. I would like to read that syllogism to you guys.
Sure, go ahead.
Just a moment, please. Okay. Speed, are you around? Can you put it on the screen? Okay. The second syllogism I will write here I will read here. The laws of physics are immutable, absolute, eternal, perfect mathematical relationships, infinitely precise in form. The laws were imprinted on the universe at the moment of creation, at the Big Bang, and have since remained fixed in both space and time. The ultimate source of the laws transcend the universe itself, to lie beyond the physical world. Laws and mathematical formulas objectively exist and originate in the mind of conscious, intelligent beings. And therefore, the physical laws that govern the universe came from God.
Okay, well, first thing, number one is wrong. Laws aren't prescriptive, they describe phenomenon. I can show you that by literally any experiment, and what you'll notice is that the mathematical function that is responsible for accounting for behavior never accounts for 100% of data. It always has a range of error. If laws were prescriptive and not descriptive, there would be no reason at all to have statistics.
Well, the fact is that the universe, it behaves upon these physical laws. And
yes, it does. And however, what is also true,
and that demands an explanation.
The laws are descriptive of what we're observing.
Okay, we describe them, but the question is that they exist, and that demands an explanation. This state of affairs, that laws, physical laws, govern how matter and physics behaves, that could not be so necessarily. It could be different, and then there would be no laws and no physics at all. So the fact that matter behaves based on the physical laws, that demands an explanation. And we know that intelligence can set up these laws and then can make them perform specific things. But that state of affairs is not natural. Why should it be so?
The question of why is a worthless question. But to answer your other question, if it's the case that there are other universes that can form complex structures like atoms and molecules and whatever, it simply means that there is a more fundamental theory at the core of physics. It means that there is a physical theory that describes how these fundamental constants are related to each other and how you can change one value of the fundamental constants and the others, and how the others would change in proportion. That's all that means. Why certain things exist? You might ask the question, why did a squirrel lay a particular nut on a very specific tile of concrete? Did it intend to put it there? Was that intelligently designed? No. Some things simply are.
So you resort basically to a brute fact, but that is where we disagree, Immutable. The first syllogism here, I am writing, laws and mathematical formulas objectively exist and originate in the mind of conscious, intelligent beings. We have empirical evidence that minds can generate mathematical formulas. And the physical laws that govern the physical universe, therefore, had to emerge from a mind, and we call that mind God.
Okay, in that case, let me ask you this question. If minds are the construct of human beings or intelligent agents, doesn't necessarily have to be human beings. Let's imagine that me and you live, for instance, in a time, I don't know, let's say in ancient Egypt, a time before we did not yet have modern science or mathematics that was sophisticated enough to understand these behavior. But at that time, it's very well understood that the Egyptians did not have an understanding of electromagnetism, and they did not have an understanding of the theory that underlies electromagnetic behavior. Since there were no laws at that point that could describe that behavior, does that mean that that phenomenon that are subject to electromagnetism didn't exist because there were no laws that could govern that behavior?
Of course, the laws, they were implemented even if we still didn't understand them or describe them. But that is the point, Immutable. These laws did not have to. These laws, we only know that is a fact. Laws and mathematical formulas objectively are generated by intelligence. This is what we know, and we know that the physical.
Okay, but the fundamental point, and maybe it wasn't clear from the argument I was giving, is that the law that we describe has nothing to do about being prescriptive, right? Because there was that phenomenon that was existing before it was described.
Okay, but it was implemented. It was implemented independently. If we were able to describe it or discover it or not, it was there. We know that the physical universe operates orderly based on these laws.
Right. Right. But the types of laws that are being assigned to these are descriptive laws, not prescriptive. No scientific law is necessitated.
I am coming to a limit where I don't know how to make my point more clear, Immutable, because you keep repeating that, and I agree with you. Of course, we are describing what we discover. We discover that state of affairs, that physical laws, they govern how matter behaves and how it is orderly, and it permits the universe to be stable. But the fact is that it didn't have to be that way. Why is it that these physical laws exist? And there is the crux of the issue. We only know of intelligence and minds which can formulate laws and then implement them. Random luck doesn't formulate and implement these laws.
Okay. The fundamental issue though is that the way in which we know those laws, the framework that allows us to know that, is violated by the type of argument you're trying to create. And that's for the reason that, for instance, if me and you, for instance, were to go to a car dealership, or actually, let me make it a little bit different. Let's say me and you are taking a drive, and we see something weird. Say we see an abandoned car on the road, and we pull over and we ask, well, that's kind of weird. I don't know where that car came from. Doesn't appear to be anybody in that car. It's a nice blue car that's on the side of the road, appears to be fairly in the middle of nowhere. Where did this car come from? It definitely doesn't seem to be something that would just, pop up. But when we ask the question about where the car came from, for instance, right, there are certain qualities we look for to be able to say, well, that thing isn't normal. Okay, this thing is highly ordered. This thing has, characteristics that we wouldn't expect to see in the natural world. There are certain things that exist in this car that we've only ever observed human beings create, and that are only the product of an intelligence. And when we formulate those theories, we can then go back and say, okay, this car, based upon certain characteristics it has, seems to be that it was made, by Ford or whatever. And if we're curious about that, we can then verify, oh yeah, we talked to one of the representatives from Ford about the types of characteristics we noticed on this car that seemed peculiar, and that seemed to be that it would be a property of an intelligent agent. And in fact, it was. There is in fact a way of verifying that. With God, the fundamental issue is twofold. The issue is, number one, there is no way to test for the type of God that you're describing. There is no way to test for the type of God that is transcendental, that exists outside of space and time. But the other fundamental aspect is, we know, based upon geologic data, we know based upon the limits of archaeological data and many other things, that human beings have not existed forever. Human beings, according to evolutionary theory, started to exist about 2 million or so years ago. That's about the rough ballpark. But prior to that being, there were different life forms that did not have the level of complexity we did, that were able to create machines or other complex objects that were of the same level of complexity. And so the inference of intelligence goes so far because we know, for instance, that intelligent agents can create certain things, and we also know where those things came from, and we have evidence to say, for instance, that it was humans that made the ancient pyramids and not aliens or Martians from Mars. With a god for something like that, we have no precedent to say that such a thing could even possibly exist, or that anything does exist. And even if it's the case that this thing does in fact exist, how are we supposed to know that? How are we supposed to say, oh yeah, this is where this thing exists. Oh yeah, here's the message that God was intending for us to find somewhere in the middle of the Andromeda galaxy that actually confirms our prediction that God is real, or that God is a true thing.
Okay, so let's suppose that you see that the same car which you described now, and we have no way to trace back to the factory, Ford or whatever, and we have no idea to verify which factory that made that car. Does that mean that we have some doubt that rather than some company made these cars, tornadoes or natural occurrences made these cars? Is there some doubt in regards of that? Or would you say, okay, we cannot verify which company made that car, but we know it was intelligence, engineers and so forth, which made these cars?
Right. We would say it's likely an intelligence, and the reason, like I explained in my own.
Okay, so you can infer intelligence even if you cannot verify that intelligence made an artifact, correct?
Yeah.
Okay, so now gravity is inferred by observing an apple falling to the floor. Is that correct?
I'll accept that. Yeah, more or less.
Okay, so the existence of a non-physical, non-created creator is inferred by observing the existence of a finite universe. It's the exact same procedure of thinking.
Okay, the only thing I see, right, if I observe something that's not finite, or something that's finite, right? So, like with the car, for instance, if me and you have been traveling down that road many times before, if it's not our first occurrence, what I could say is that there were times in existence, there were times in which we were traveling down this stretch of road and there was no car, and there's a time now where we are traveling down this road and we do observe a car, and still the only reason, or one of the only reasons, that grounds the fact that we can say this car is likely the product of an intelligent agent is that, like you were saying, even if it's not the case where it's something we precisely know the identity of, maybe it doesn't belong to Ford, maybe it belongs to Honda or whatever, I don't really care. The aspect of it, the fundamental quality is that, look, these are properties that we know for a fact are only the products of a mind. These are things like an engine and a radiator and certain other structures that we're observing here. Even if it's not identical to some car that we know exists and that's produced by some company, we know that this is the product of similar activity. And we've never observed it occur in nature. We've never seen nature just out of nowhere produce a car. So for that reason, even if we don't have a precise identity of what it's like, or of what the car exactly is, or where it exactly originated from, the fact that the characteristics it shares are similar to other things seems to imply, because an intelligence is the only thing that can create those things, that this is the product of an intelligent agent.
I agree with you.
Right, but with something like gravity, for instance, we don't see the same type of thing. What we see, for instance, is if I drop a ball, or if I hold a ball some distance in the air, and then I let go of it, it drops. Okay, well that's fine. we also observe gravity on larger scales, where certain galactic bodies or certain objects like planets and other things in our Milky Way galaxy are orbiting around their local are orbiting around stars that are the centers of their solar systems and what have you.
Yeah, Nestling earlier today, before our stream started, he put a link to a science paper which was trying to claim that cells are not machines. And
They
it
aren't.
was, well, but that's what he claimed. And he made me a great service. I then actually did read the paper. I made some criticisms of it. And what is on the screen now, that is one of the sentences which I am pointing out here in point 1, which I made a new syllogism tonight. So I would like to read it. The
Go
cell
ahead.
coordinates its functions by virtue of a genetic program encoded in the DNA that directs and controls the expression of a specific set of RNAs and proteins, which assemble deterministically into stable molecular machines that reliably and efficiently execute predetermined operations according to the mechanisms of cell division, endocytosis, signal transduction, etc.
Okay, can I hold on?
Now, I would like to finish that, then we can talk about it. Secondly, this is analogous to engineers which produce blueprints which prescribe and instruct the making of and assembly of machines for specific purposes. Now, we have here an analogy, and the three, if the analogy of two phenomena are very close and striking, while at the same time the cause of one is very obvious, it becomes scarcely possible to refuse to admit the action of an analogous cause in the other, tough, not so obvious in itself. A metaphor, a biological cell is like a production system, demonstrates that similar behaviors are driven by similar causal mechanisms.
There's a fourth one, right?
Yeah, and since there was no human mind present when life started, we can conclude that a non-human higher intelligent agency must have created life.
Okay, so let me go through each of those because there's issues I have with them. The first thing is that the order for which you're assigning the activity isn't correct necessarily. And the reason for that is proteins where it says the DNA that directs and controls the expression of a specific set of RNAs and proteins.
That's from the science paper, okay?
Right.
That's not me. That's what I just copied from the science paper.
Okay. The issue in what you're trying to use it for is that it's understood that proteins also play a role in regulating their own activity as well as the activity of DNA. For instance, you have various proteins that are responsible for that essentially act as a channel for certain ions to pass through. And these, for instance, so certain voltage gated channels, so channels that allow sodium and potassium into the cell, for instance, have essentially a ball-like structure at the end of them that can bind to it and essentially will prevent other ions from going in once there's a certain concentration reached. But the point being is that the certain proteins respond to various levels of chemical activity. So some proteins that receive a substrate, for instance, like ATP or whatever other substrate it happens to be using, it will respond in some way if it has a small amount. But if it has a large amount, it will act differently, and that's because when enzymes are given a molecule to react with, or a molecule to be housed with them, if that molecule is being transformed by means of a metabolic reaction, there is only so much that enzyme can do in terms of its ability to speed up a reaction. So essentially, if there is more of the molecule than the molecule can turn over, that molecule will have an effect on the protein, and it will cause other proteins in the cell to change their activity. And that, in turn, may have an effect on elements such as the activity of certain genes or the activity of RNAs or any number of other things. So yes, DNA does play an aspect in terms of the expression of proteins, although the opposite is also true. So when there is an abundance of a certain substrate, that can also cause proteins to exhibit behaviors that ultimately will cause more protein to be transcribed. So it's a dynamic relationship. It's not necessarily strictly the case that DNA prescribes the information of a cell. It's that what the DNA does is that DNA has coding regions that specify specific amino acids and also, to a higher extent, proteins that can be produced. Those proteins have some function in a cell, and over time, over the course of a cell's lifetime, which can be radically different based upon what type of cell it is, those cells, their activity will change based on the activity of the proteins, which also have an effect on the DNA. So this process operates in tandem. It's not necessarily that the activity of a cell or the activity of DNA is prescriptive. In many ways, it is a complex interaction between DNA and how it's being expressed to create protein, and also how proteins are being created and responding to environments that direct the activity of DNA.
Well, I agree with everything what you're saying, Immutable, but that makes your case actually even worse, because you are describing a circle here which has no starting point.
I disagree. And so the reason I disagree with that is certain enzymes have an affinity to towards DNA in different ways. So some enzymes have an affinity towards DNA in the respect that they will bind to DNA very tightly, meaning they will cause repression, meaning that transcription will not occur.
Yes,
Some
transcription factors. I know. Yeah, I know.
Yeah.
I know. Yeah, but still, that will cause another loop. You know that transcription factors are encoded by DNA, but
right.
You need transcription factors actually to express DNA to orchestrate the expression of DNA. So of course we can ask what came first: the genes, the information in the genes which make transcription factors, or transcription factors which regulated the DNA to orchestrate the expression of DNA. That had to start all together.
Well, so I think something that's fundamental, and this would be good to have Demeter on at some point to go through this. But so something that's a fundamental that's of importance here is that proteins in cells do have catalytic activity, so they do engage in metabolic activity to transform something into something else. However, they are not the only thing that does that. There are a class of molecular entities called ribozymes. Some of them are strictly RNA-based, wherein you have a specific strand of RNA. That RNA strand, based upon its structure, will fold in a very convoluted fashion, and the folding that RNA adopts and the geometry it has sometimes is favorable to permit certain chemical reactions to take place. And so, in fact, this is exactly what cells do. Proteins proteins facilitate some chemical reactions, but not all. And in fact, if we're talking about the ribosome and tRNA, the tRNA only has activity in terms of the fact that the anticodon and codon will bind to each other, and then a very small segment of that of the protein that's actually responsible will essentially find a specific portion of that of the codon-anticodon pair and begin to facilitate a chemical reaction, transferring one amino acid, beginning the synthesis of an amino acid. And it does that by virtue of allowing one RNA strand to bind with another.
Okay, Immutable. I don't think that I agree with all the descriptions which you are making, but my point here on point one is simply this: that the information in DNA, as I pointed out in point one, coordinates the functions by virtue of a genetic program encoding the DNA that directs and controls the expression of a specific set of RNAs and proteins, which assemble deterministically into stable molecular machines. So we have here a relationship of, on the one side, instructional complex information, which directs the making of molecular machines. We have here a relationship where information controls and directs the making of molecular machines and factories. That is what is described in point one. And this is analogously to what we do. An engineer, he produces a blueprint which prescribes and instructs the making and assembly of machines for specific purposes. So we have here an analogous situation. And the point here is, in point three explains it, when you have two things where we know it is obvious that human engineers make blueprints and then make machines and so forth based on these blueprints. And we have the phenomena in the cell where we do not have a knowledge about how this situation and this state of affairs emerged and began to exist. But we know that even if we do not know how it came to be, we know by experience that intelligence makes blueprints, and upon these blueprints, then machines and factories are built. So we have here an analogous situation, and we have an obvious cause, which are humans making blueprints and machines, and we have an unknown cause, but a similar effect. Then it is logical that we posit also an intelligence for that other phenomena, which is analogous to the one which we know that exists in humans, in human experience. That is basically a logic, Immutable, which I am providing all along during all these months. And you have provided a very good example with the car. If we do not know who made the car, we still can infer that intelligence is the best explanation, even if we cannot test that intelligence made these cars. But it is the best explanation because by experience we know that humans make cars. And that's the same situation here. We have not a time machine to go back to see how life emerged, but we have this situation which is analogous to ours. There are blueprints which instruct and control the making of molecular machines and factories. That state of affairs, it has never been shown to emerge by unguided random events.
So I take issue with what you're calling unguided and random. What you're more than likely trying to achieve with that is by saying probabilistic. Which, yes, chemistry is probabilistic.
Our argument, okay, yeah, I don't. Well, if you put probabilistic, is it probable that unguided random events would make a car?
No, and the reason for that,
Of
like
course, there is a probability. Of course, there is a probability, but that
it is, it's just
probability
very,
is
very low.
so tiny. That probability immutable is so tiny that we can basically exclude it as a plausible, rational explanation of how cars have been made.
Okay, so let me provide you with with a few things, which is number one. Okay, let's see if we can agree on this one first. The activity of proteins, or the final result of what proteins do, is to increase the entropy of a system. Yes. Right?
I think you are again not addressing the
I'm trying to. It's just gonna
point which I am making, which is the relationship between information, which is stored in the genome, and the product, which are molecular machines and cell factories, and information in the genome, which is controlling and dictating how that cell factory has to behave. That relationship has to be explained, and that is the crux of the issue here.
The fundamental issue I'm having is that although chemistry is probabilistic, it behaves under a set of very well-ordered principles, and those chemical principles allow for complexification under certain conditions.
Immutable, there are no principles which dictate the sequence of nucleotides, because any kind of sequence of nucleotides can be sequenced. There is no physical necessity or attraction of the sequence of nucleotides. You can sequence any of the 4 bases and make any kind of combination.
Right, although the current models that are explaining the origin of the genetic code have to do with the relationship between...
No. We are talking here about the information, not the genetic code. The genetic code has to do with the assignment of codons to amino acids, but the crux is the information stored through the genetic code in the genome. That sequence is not pre-ordered by some kind of physical necessity. It is free. Any sequence is possible in the genome, and similarly likely, in the same sense, like when you have a drawing board and you have letters to write a sentence, then there is no physical necessity. If you want to write coordinates, then you take the letters and sequence them, and there is no physical necessity which dictates that the C comes before the O and so forth. That is free. That is unconstrained. And the same occurs in the genome. The sequence of nucleotides is not dictated by physical necessity. So you cannot invoke that chemical reactions are an explanation of this.
I don't know. I still think you can, in the sense that when you think about the functions of certain amino acids, so if you think about the functions of, say, alanine and glycine are both very, very small molecules, and they cause rigidity within a structure to occur. They do they allow rotation, but they do not allow for the protein to really rotate that much, because they're very small little molecules. And the reason those would be assigned is that when proteins are being first experimented with by biological systems, it's most important to have a system that is stable. So to have a chemical reaction that's being catalyzed, but not having it catalyzed in a way that the structure is rotating all over the place. You want the type of catalysis to occur in such a way that it's stable. And so for that reason, whatever the association between the genetic code and these RNA molecules happens to be, would favor a catalysis that's stable over not stable. The reason for that is the second law simply states that entropy in a system of a closed system increases over time. Well, catalysis is a means by which to do that, because what catalysis does, essentially, is it speeds up the reaction, or it speeds up the number of reactions that can take place by lowering the energetic barrier for 2 molecules to interact or react with each other. And so in that way, if you have a stable catalyst as opposed to a non-stable catalyst, entropy in a system is going to be maximized more. So it would favor that type of interaction to occur.
But I am not talking about amino acids, immutable. I am talking about the sequence of nucleotides in the genome, which is free and unconstrained. And
right. I'm talking about.
Yes, but that is my point, that sequence is which instructs, which is the blueprint, which is the information, which directs and controls the making of proteins. And that is the same situation as a machine designer, I sit on the drawing table and I make the blueprint in order to make human-made machines. So we have here an analogous situation. And we know that I, as machine designer, I have the intelligence to make a blueprint for a machine, to construct a machine with a specific purpose. And the same function as the genome, which stores the information to make molecular machines. And that sequence is not dictated by physical necessity. It is unconstrained, and it must be so, because if it wouldn't be so, then it couldn't be an information-bearing molecule. And that sequence requires an explanation. And it is very unlikely that a correct sequence of millions of nucleotides would emerge prebiotically by unguided events.
To me, at least, what seems to be the case, and a lot of theories are postulating this, is that the development of the genetic code is something that would be a sequential process.
No, not the genetic code. You are conflating the genetic code, which is another problem, with the genetic information. That are two different problems, Immutable. The assignment of codons to amino acids, that is a huge unsolved problem, because only intelligence does make assignments of meaning. But on top of that, you have to explain the origin of the information, which is the sequence of the codons, which are functional and information bearing, and instruct the making of the proteins. But on top of that, not only do you have that layer of information, but you have also the cis sequences, which are another layer of code in the DNA, which instructs the transcription factors to bind at the right place in order to be the information to be expressed. So you have various layers of information which you require an explanation for, and I don't see how you can get to how you can explain the correct sequence by natural unguided means. That's the crux of the issue and the big problem.
So I think the fundamental issue here is that, at least as it pertains to the origin of the genetic code, or perhaps the genetic code itself,
that is another big problem.
Yeah, I think that the sequence of amino acids and their preponderance is actually directly related to DNA itself. And I think that's because there are certain so if we think about the system at its most basic level, in terms of there being, say, some sequence of RNA that's just floating around, perhaps it's in a protocell or whatever, and there might be random amino acids that are occurring. Some things are known about amino acids in terms of interactions that they have with, in terms of interactions that it has with DNA. For instance, lysine and arginine, for instance, are known to stabilize the structures of DNA and RNA, and they're known to do that by, number one, undergoing ionic interactions with DNA, but they also do that by a different means, whose name escapes me at the moment. Irregardless of that, the important aspect at a conceptual level is that experimentally, it seems to be the case that certain amino acids have a very strong have chemical interactions with DNA or RNA that stabilize those structures. And as the result, if there is some chemical reaction that can occur in which a DNA molecule can facilitate the growth of a polypeptide, that preservation, that sequence, essentially, would effectively have an assignment with that amino acid, since the two are synergistically operating with one another.
Well, that scenario is completely different from what we see in modern cells, which is, the central dogma, which is going from DNA to messenger RNA, and then to amino acids, and to go from that scenario, which is which Dimitri is proposing, to the situation, the advanced complex situation in modern cells. That's such a huge leap. It is the same as to say, well, there is some attraction of two metals to go to a hadron collider. That would be the same gap, the same leap.
No, so let me explain why I think that's not the case. So with very small chains of amino acids that are stringed together into a polypeptide, if you have, say, 10 or 15 of them, the best it can do is begin to form an alpha helix or a beta sheet. So it's a very, very simple little structure that amino acids form, and they form it because both ends of the molecule, if it's too long, actually prefer to fold in a way that you have other interactions like hydrogen bonding occurring. And okay, fine, but the capability of that protein is limited because it can't because it can only catalyze certain reactions. However, when there's more energy available to a system, if some of these proteins happen to facilitate chemical reactions that generate more energy, so the fixation of phosphorus or production or hydrolysis of ATP or something like that, now that you have more energy to play with in a cell, you can also begin to essentially synthesize longer and more random strains of amino acids that catalyze a broader host of chemical reactions. And as the result of that, now you actually have the ability for a proper association to begin. So proteins that are longer and happen to have a stronger affinity in catalyzing a certain type of reaction, maybe based upon the strength of an amino acid to some active site of an enzyme, would then cause a more understandable association between proteins and their association with the genetic dogma, as opposed to this kind of original primitive system of peptides having a mutually beneficial interaction with polypeptide, or nucleotides having a mutually beneficial interaction with small-chained amino acids.
Immutable, you are making here huge leaps of faith. These are hypothetical scenarios, which there is absolutely no empirical evidence that these kind of scenarios are plausible or could actually happen. And even the selection of the 20 amino acids which are used in life, that is an unbreachable problem. There was no selection process to select those which are used. And in regards of nucleotides and the other basic building blocks, it is the same situation. There was no selection process for the nucleotides. And I've seen you and others making these hypotheses, and the entire abiogenesis community is doing these scenarios for 70 years Immutable, but the fact is that the description of a protocell of these kind of things which supposedly somehow prebiotically chemically evolved to the organization which we see even in the most basic simple cell, it is a huge gap. It is a huge gap. And once you realize that and come down to the conclusion, hey, but what I am thinking about here, that is simply not plausible. It is not logical. It is a too big leap of faith to go from what I am proposing to what we actually see. Then maybe you will start to see what we understand, which is that
the issue is I don't see that big of a leap. What I see, for instance, is that there are certain things that cells require. There have been, as you correctly pointed out, there are systems that propose that, for instance, that a series of 6 nucleotides or 8 nucleotides could work, and they don't even have to be the same as the ones we normally use. It could be any number, although there are barriers, for instance, that would limit that process. Number one is that, for instance, how metabolically costly is it for a cell to be able to synthesize some product, be it a new amino acid, be it whatever? Sometimes it's simply the case that for a cell to try and create something, it takes an excessive amount of energy. And especially when you think about the origin of life, where very early systems, if they could manipulate the flow of energy in systems, they were not perfect at it quite yet. They cannot do it to the extent that modern cells could. And so even though there's a very large array of chemical complexity that could emerge because of how many different amino acids or similar chemical species exist, it may have done that on the basis of, number one, those types of amino acids were the most abundant in the environment that this process was occurring in, and also that the types of reactions that were catalyzable by very, very primitive peptides were only capable of forming a specific set of amino acids. And so as the result, as these systems begin to complexify, there isn't a need to incorporate an exponentially growing number of amino acids if ones that can be more simple, or if ones that are simpler to produce, but that are similar enough to ones that may be more efficient actually work.
Okay.
So I don't see.
Well, the problem is that I've pointed that out many times Immutable, and it is never acknowledged as I think it should be acknowledged. If you do not have even a specific sequence of amino acids of just one protein, like in order to recognize iron to import it into the cell, you have no life. And the scenario which you are describing, which you hypothesize or which you think is plausible, it is not plausible because you are the only mechanism that you have at hand is random, non-intelligent, unguided chemicals interacting with each other, but that is a chaotic situation, and it is. I think that James Tour, he made a video where he laid out all the parts of a car and said, now imagine that somehow all these parts by unguided random events came together to form a functional car, which can be used and functions. That's the same situation as in the cell. You can take all these amino acids and nucleotides and basic building blocks, and you can see them scrambling and bunching together and whatever. That will never giving you the organization of even the smallest, most simple cell, which is highly structured, which uses energy, produces all the basic building blocks of life, makes all the components which it uses. It is a factory which imports materials into the cell. It has waste products which are recycled and which are expelled, and it adapts to the environment. And there is also lots of information also already required and in use there, which has to be generated, has to come from somewhere. I mean, I don't know if you can see what my objection is, but I cannot follow that from the scenario which you are describing. You can go from that scenario to the complexity which is required to have a minimal working cell.
Yeah, I don't, for instance, if you're asking, okay, how does that get us to modern eukaryotic life? The short answer is
not
a
eukaryotic life. No, I'm giving as an example always Pelagibacter rubic, which we know is one of the smallest free-living prokaryotic cells, and it has 1.3 million nucleotides. It has 1,300 proteins, and it is already extremely complex. It is a self-replicating factory full of machines and production lines and full of information in a literal sense.
I think we disagree, although I think bacteria actually has an important clue here, and that is the fact that once you have a primitive genetic code that's able to develop, which is at least hypothetically plausible, there are models that still need to be tested, but if they are able to work, you would have an assignment between amino acids and RNA. If you are able to achieve the production of circular RNA molecules or plasmids, so little packets of genetic material that can be transferred between cells, what you then have instantly is a tremendous and exponential growth in complexity. And that's because you now have a system where, because there's a primitive type of exchange in genetic information, both to house the genetic material and also to essentially translate that genetic material into a protein or a small peptide. Now you've opened up the doors for a very large amount of chemical space to play with. And these types of proteins, which can catalyze different reactions, will catalyze some reactions, but not others. And as the primitive genome of a cell grows, the proteins that cell produces, some will be more effective than others, and it'll continue to grow from that point, and it'll get better at what it does.
You see, you started your narrative with your supposed hopeful possibility that somehow nature could make the assignment of codons to amino acids.
And there's models that seem to.
Yeah, I mean there are many models immutable, but I think the most honest scientist trying to solve that problem is Kunin, which said that the problem of the origin of the genetic code has been with science in the last 50 years, and even in the next 50 years there will be no solution found to that problem. And that is precisely one of the answers which I wrote to Speed, where I said, I don't understand how you can even imagine that unguided events can assign meaning to things. That is something which is not warranted, because unguided events simply do not have that capacity to assign meaning to things. And this is something which really only intelligence is able to do. And that makes theism and intelligent design rational. And it makes materialism and naturalism irrational, because it is never observed that this is happening, that it can happen. But we know by experience that we as intelligent beings, we are able to make codes. We are able to assign meaning. we are able to generate information. We are able to use information to make things for specific goals. And that's what we see in the cell. And that makes the leap of faith, which we require, much smaller than the one that you guys require. You need a huge faith to believe that these kind of scenarios which you describe are actually possible. And science has not come closer to warrant that these scenarios. Right in the contrary, abiogenesis has not moved forward, not even an inch. And
Oh, it has.
well, to demonstrate the huge problem that we actually have, not to come closer to propose that material mechanisms are compelling. They are really not.
Yeah, it's still a growing field. It'll do it. It'll reach its goal eventually.
Well,
Actually,
you can be hopeful. I said to Speed, you guys can be hopeful in regards of that, but well,
I don't think the problem of abiogenesis is ultimately.
I see it as a conceptual problem. That
Be it conceptual or whatever you want to call it. Both of us rely on abiogenesis, unless you want to say God's a magician.
Yeah, of course, God is a magician. I mean, you can
Well,
propose
if you
that no
believe in
magician
magic,
made.
good for you.
You can propose that no magician made magic, and I propose that a magician made magic. And I think a magician
No,
making
I
magic is more rational than no magician at all doing magic. You know.
no, I think the most interesting thing is that we only see magicians make magic, and that magic accounts for nothing in the natural world. The reason
Well,
magic exists is because it's
magic.
able to fool people.
The greatest magic would be immutable if no agency at all, but just random natural events would make a blueprint and then would make molecular machines, and in the end, self-replicating factories and life. That would be the greatest magic without the magician. So.
I don't know. I mean, as long as that system is in compliance with the second law of thermodynamics, it doesn't seem inconsistent at all.
Well, I think that the second law of thermodynamics is absolutely not in your favor, immutable. I think
Well, when you consider
we know that the situation is absolutely I forgot the name now. I can put the quote here, and then I can read it to you. But that I think that the origin of the energy in the cell to make everything going, and the origin of ATP is also a very big problem which is not solved.
I'm not sure. I've seen several papers that seem to say that it's not that big of a problem, although there's still research to be done. I think for now we've reached more or less of an impasse. Although Demeter does want to come in if Speed wants to let him in. Speed.
Yeah, if he wants to come in, but we are already almost 2 hours here. I just want to quote here this here just quickly, okay? I think I've done it previously, but I would like to quote it again. Life in any form is a very serious enigma and conundrum. It does something, whatever the biochemical pathway, machinery, enzymes are involved, that should not and honestly could not ever get off the ground. It spontaneously recruits Gibbs free energy from the environment so as to reduce its own entropy. That is tantamount to a rock continuously recruiting the want to roll it up the hill, or a rusty nail figuring out how to spontaneously rust and add layers of galvanizing zinc on itself to fight corrosion. Unintelligent simple chemicals can't self-organize into instructions for building solar farms like photosystem 1 and 2, hydroelectric dams, ATP synthase, propulsion, motor proteins, or self-repair, p53 tumor suppressor proteins, or self-destruct caspases. In the event that these instructions become too damaged by the way the universe usually operates, abiogenesis is not an issue that scientists simply need more time to figure out, but a fundamental problem with materialism.
As I said, I think we've reached an impasse so far, but it's been a good conversation. So if Demeter wants to talk and carry on this conversation.
Hello,
Yes, hello, Dimitar.
can you hear me?
Yeah, we can hear you.
Okay, I've been listening, so I will speak a little bit softer because it's too dark at the moment. So, a few things I want to mention because all of you are very tired and I'm tired also. But a few things. So, first, about the analogy, why, if you see just a car, outside car, the most possible explanation that this car is by intelligent build-up is because we cannot explain how this car naturally can be formed. That's why the most possible explanation when you see a car is to be intelligently designed. Simple as that. However, this is not the case with the biological world because you have explanation, very natural explanation of almost everything that you have. Even if we don't know the details sometimes, because science is science and do not know everything, we still have a plausible explanation for the things based on a law, based on a physical-chemical interactions. That's one thing I want to mention from your previous discussions. The second, very frequently, you, Otangelo, is using something like that there is no need of sequence to be that sequence or to be selected, or there is no need sequence to become information or something like that, as far as I remember, right?
Yes, correct.
Yeah, so that's completely false. It's not true. The sequence became a sequence, and it's exactly this sequence because it's executed into the function. So, because this particular sequence provides a specific proteins, and these proteins interacts in a specific way because of the sequence, and those give a very clear uh, advantages for survival. That's why this sequence is preserved. Initially, you have random sequences, but some combination of the sequence provides better stability. That's why it's preserved, and that's why you have a particular sequence. So to say that sequence does not have needs to be this sequence, it's completely false. It's simply not true. The beginning of information also is very clear. It's very well proven. You have a selection forces because of the sequence. And I told you many times that you have clear reaction which can prove selection of sequence because it became more stable. It's so simple. You have some sequence, and this sequence interacts with some peptides, and this is more stable situation. Guess what? When it's more stable something, it will stay. I don't see any problem with this. I hope you agree with me. Also in the 90s, probably 90s, and after that follow several times, has been shown clearly how a specific sequence can emerge experimentally. For example, Orgel and Wu and many other initially, this is from RNA world hypothesis experiments, try to do a non-enzymatic replication of RNA. So he put nucleotides over a template of RNA. And what he realized very quickly that this reaction actually occur as a template and as a replication only and mostly in GC-rich RNA, meaning you must have G or C in order to go relatively fluently in these conditions. Here we go. You have a clear selection, proven experimentally, that GC-rich RNA in that case will stay because of non-enzymatic replication. You don't need a longer RNA for that. You just need to have template. So again, another false. You have to understand that information is not just something that is virtual and not existence. Information is result of specific selection because of this sequence. So I don't see why you cannot understand that simple phenomenon.
Dimitar, I honestly, I'm a little bit tired. There are so many things that I are worth to be addressed, what you just said. And I hope that we can have eventually another opportunity to go into the details. But many things that you said, I have actually addressed in one of my emails. And I've not seen any reply of yours. You blamed and said, "Oh, Otangelo wrote so many things; it would take hours to address each of these points." But we can do that. We can go into the details and each of these points. Take your time. I'm not pressing you, and we can look these things up. I think whatever I would say to you now in 10 minutes would not be enough time to go into more detailed into to address what you exposed right now. But I'm open that in another moment or so that we can discuss all these things. Would that be okay?
Only if I have time for that.
Yeah.
At the moment, I might have time just maybe Saturday or Sunday for
Yeah. There is
sometime
there's-
around 10 o'clock.
yeah, there is no hurry. We can exchange. You can write me when you have time, and we can set up something, and then we can discuss these
Just
things.
I just wanna repeat again the notion that the sequence does not have need to and following sentence. It's not correct. Also, it's not correct to say that the information cannot occur just by natural forces. This is simply not true. Okay, guys, I will leave you.
Can you hear me?
All right. Well, I think it's been a pretty good stream. If he wants to wrap it up,
Midnight arrives late to the party.
Yeah, well,
So, Otangelo, you and I have a talk about some of the recent comments. I have just a few questions for you about some of them. So
Okay.
we should do
Go
that.
ahead.
And so maybe we'll do that next.
Okay.
Have a talk. So anyway, cool guys. You guys were you didn't overtalk each other. That's nice. So
Yep.
cool. So you want to end it?
Yeah, I guess so.
Okay, we're ending, guys. We're goodbye out there in the world. Wherever the
Thanks.
fuck that is.
Yeah. Thanks, Speedy, to have me again at your channel. It is always a pleasure to talk about these things, which we are all passionate about. And
Yep.
let's keep going.
Okay. Okay, bye guys.